Hey, hi there. I'm Vibin Thomas, and in this video, we'll explore how Model Context Protocols, or MCPs, can change everything about how AI assistants operate and why it's potentially the future of AI and application interfaces. But first, it will be good if we understood the evolution of AI assistants. The first wave of generative AI LLMs were large language models like GPT-4 or Claude that have incredible general knowledge and reasoning abilities that was learned from very vast amounts of training data. They are great at understanding text and generating text that mimics human intelligence to an extent by predicting the right set of words in response to what you've asked the AI. However, if you're chatting with an AI assistant and asking questions about your own files or company data, today that AI is likely stuck. It doesn't automatically have access to your documents, databases, or tools. And for all their intelligence, even the most sophisticated models often end up trapped behind information silos. So in wave two, we saw custom integrations coming up that linked to an LLM based AI assistant and gave it access to data and tools. Each new data source, for example, a file system or an app or an API, usually needs its own custom connector or plugin. Now, this fragmentation means a lot of duplicate effort for developers and a patchwork of integrations that can break or become outdated. So, if every team or product has to reinvent the wheel to connect to an AI, say their CRM database or Slack message, it's hard to scale AI assistants and scale it across an organization. It's like having to build a new adapter for every single device you want to plug into your computer, and it's clearly inefficient. So, without special integrations, an AI's knowledge is limited to its training data. So, out of the box, it can't know about yesterday's reports that you put into your SharePoint, for example. And this leads to the AI giving generic or outdated answers unless we bridge this gap. So, that's where the model context protocol becomes very relevant. The MCP, it's an open standard that promises to break down these information silos. It was first made public and open source by Anthropic, the parent company of the Claude family of AI models. And the main goal of the MCP project is making it easy for AI assistants to connect with the world of data and tools around them. An easy way to grasp it is by the analogy, think of MCP as a USB-C port for AI applications. So just as a USB-C provides a standard connector, so any device, whether it's a phone, camera, or a hardware device, you can plug it into your laptop. And the MCP provides a standard way for AI models, similar to this, to plug it into various data sources and services. In more concrete terms, MCP defines a common language or a protocol that both an AI client and a data or tool service can understand. Here's how you can break down the structure. So there are these things called MCP servers. These are lightweight connectors or adapters that expose a specific data source or functionality. For example, one MCP server might connect to your local file system, another to Google Drive, or something to an email mailbox, or some kind of application that you have. Each server knows how to fetch information or perform actions on these specific services or domains. Now, the MCP client, this is the AI or the application using the AI chat capability that wants to access these data sources. The client doesn't need to know the nitty-gritties of each service. It just sends a standardized request via something called an MCP. The MCP is the standardized protocol and how the client and services communicate. Think of it as a common language that allows them to send requests, get responses, do authentication, and all the other fancy stuff in order to collect information, read information, or do specific tasks. Because it's open, multiple AI providers and tool developers can adopt it and ensure compatibility across the board. In a typical MCP interaction, the AI or the client might say something like, hey, I need all the files mentioning project X through the MCP interface. The MCP servers for your file system hears that and retrieves the relevant information and sends it back in a standardized format that the AI can understand. The AI can use this information to answer specific questions or perform whatever tasks it was planning to do. The AI didn't need custom code of how to search specific files for that application. It just issued a general request, and the MCP server handled those specifics. Now, once a MCP server exists for a data source, any MCP-enabled AI can tap into it. It's a huge shift from the current state where, say, one team Slack bot might not know how to query a specific database, but another app would have to re-implement that full logic from scratch. With MCP, they both just use the same standard protocol, talk to the same database connector. It's one universal adapter instead of a dozen of bespoke ones. Now, MCP brings several benefits that can make AI integration smoother and more powerful. First, it's plug and play. A growing number of pre-built MCP connectors are becoming available for popular services. Already there are open source MCP servers for Google Drive, Slack, GitHub, and a couple of databases and more. Now, this means an AI assistant can directly plug into these systems once you have the connector set up. No need to write custom integration and logic every time you need a connection to an application. And so there is standardization. So instead of many fragmented APIs and a plugin, you get one standard protocol. Developers can build against a specific MCP and know that it will work across various sources. This gives flexibility. The protocol isn't tied to a specific AI. So that means today you might use it with Anthropic's Claude and tomorrow another AI, say from OpenAI or an open source LLM. And that could adopt the MCP and immediately gain access to the same connectors. This flexibility protects you from being locked into one AI vendor. So if your data pipelines speak to MCP, you can switch out or upgrade the AI model on the other end with minimum fuss or challenges to transfer. Security and control. Because MCP connectors can be run locally or within your infrastructure, you maintain control over your own data. For example, you could run an MCP server that interfaces with an internal database on your own secure servers. And thus, the AI assistant, even if it's hosted elsewhere, only gets access to specific pieces of data that it asks through the protocol. This setup follows the best practices of keeping data secure within your environment, while still enabling the AI to use it. Then, of course, there is developer efficiency. Developers can focus on building new features instead of continuously writing glue code or connectors. They can now contribute to or reuse existing MCP servers for common systems. And over time, as the MCP ecosystem grows, it's likely that there is an MCP connector for that specific task that you want to get done. Much like what you would expect for a device that will support USB or your Bluetooth today. This saves time and reduces bugs since standardization of connectors tested by community rather than every team rolling out their own integration. Companies can find lots of efficiencies. Now, there are also early signs of adoption. You have developer tool platforms that are working with MCPs to let AI agents fetch relevant coding context from the files and repositories. And this helps them produce more accurate code with less trial and error. Even Microsoft has taken notice. For instance, Copilot Studio, Microsoft's AI development toolkit, announced support for MCP so that it can directly connect to various knowledge sources through the protocol. This momentum suggests that MCP is not just a theoretical idea, but something that's quickly becoming practical. Now, in summary, the model context protocol might sound technical, but it's promising with a lot of exciting applications. And it makes AI assistants truly useful by giving them standardized access to the information and tools that they need. For developers and organizations, MCP offers a path to integrate AI without integration headaches. You can build a connector once and use it everywhere. And this fosters a collaborative ecosystem. As more connectors are available and are created, the community collectively gains a rich library of AI plugins for any system that you can think of. It's analogous of how the open source movement provided reusable libraries. Here we get reusable data or tool connectors. Now looking ahead, if MCP or a similar standard gains adoption, We could see a future where AI assistants are as easy to connect as, say, Wi-Fi or Bluetooth devices today. You might go from one environment to another, and your AI can carry context with it because every platform supports these standard protocols. The dream of context aware AI and assistants that remember your preferences, utilize your resources, and act on real world data becomes much more achievable when there's a system or a common road or language for communicating between applications. In short, the MCP is a significant step in making AI not just smarter, but also useful. It's part of the evolution from isolated AI models to AI systems that are already deeply integrated into our daily lives. The next time you interact with an AI that can pull in answers from your knowledge base or execute tasks that you ask it to do on an application, there's a good chance the technology powering it might be something like a model context protocol. So that's it for this video. So till we meet again, keep learning, keep building, and keep exploring.